Hi students, and the second part of study of arches. So we will see some equations of circular arch, parabolic arch, and some problems in circular arch. First, let us go to the equations of circular arch. In the given figure, you can see a circular arch. A circular arch is a part of a circle. Okay, so R is the radius of the circle, L is the span of the arch. Then from the property of circles, we can write like this. L by 2 into L by 2 is equal to h into 2r minus h, where h is rise of the arch. This is the rise of the h is the rise of the arch. Okay, L by 2 into L by 2 is equal to h into 2r minus h. Now, suppose we are taking the case of a parabolic arch, then taking springing point as origin, springing points, that is, these are the springing points, these are the springing points. Suppose we are taking springing point as origin and x and y are given as coordinates, then y can be written as y is equal to 4hx by L square into L minus x. Suppose we are taking crown as origin. Suppose we are taking the point C, that is crown as origin. Then equation of parabolic arch is given by, suppose we are taking like this, crown as origin. Then equation of parabolic arch can be written as x square by y equal to a, where a is a constant. Suppose we are taking x is equal to L by 2. At x equal to L by 2, we know that y is equal to h. Okay, so x equal to L by 2, y equal to h. Let us substitute. L square by 4h we will get as a. Then equation is given by x square by y is equal to L square by 4h. Suppose springing points are not at the same level. Let h1 and h2 be depth of abutments from the crown and L be the span. Then we know the equation x square by y equal to constant. Suppose we are taking x equal to L1, y equal to h1, x equal to L2, y is equal to h2. Then we can write it as L1 by root h1 is equal to L2 by root h2. That means by the property of proportions, that will be equal to L1 plus L2 by root h1 plus root h2. L1 plus L2 is equal to total span of the arch, which is equal to L. So that becomes L1 by root h1 equal to L by root h1 plus root h2. These equations you can use for solving L1, L2, h1 or h2, whichever is not given in your problem. Now let us derive the equations for radial shear and normal thrust. You can say V is the vertical shear, Q is radial shear, and N is normal thrust. You can say diagrammatically they are represented like this. And theta is the angle between N and H. So N can be written as equal to V. You can say this angle is theta. So this angle here it is 90 minus theta. Okay. So N is equal to V into this angle, that is V into cos 90 minus theta, that is V sin theta, plus the component of H along n, H cos theta. Similarly, Q can be written as Q is equal to, see, you can extend V downwards. You are extending like this. If this angle is theta, then this angle is also equal to theta. Okay, this is also equal to theta. So Q can be written as P cos theta minus H sin theta. Q is equal to, this angle is also theta. This angle is also equal to theta. So V cos theta will be acting in the direction of Q, and H sin theta is acting opposite direction. So V cos theta minus H sin theta. These are the basic equations for N and Q, which we will be using in the solution of parabolic arches or circular arches. Let us go to a simple problem. This problem, a 3-hinged circular arch hinged at the springing and at crown points, has a span of 4 meter and central rise 8 meter. It carries a UDL of 20 kN per meter over left half of the span with a concentrated load of 100 kN at right quarter span. Find friction supports, normal thrust and shear at a section 10 meter from left supports. So you can see a figure given here. Left half you are having UDL. Right quarter span you are having a concentrated load. you should find forces at a different point D, which is a 10 meter from left support. Okay, so how we will proceed here? We will first find out vertical reactions VA, VB. Then you should find out horizontal reaction H. Then how we can find horizontal reaction? By taking moment towards the top point, that is the crown point C, you can find out horizontal reaction H. Once you find H, you can find the N and Q at D. Given you find vertical shear at D. You should find out the shear force at D. Then you can find at the values of N and Q, which are given by equations. First, let us find vertical reactions VA and VB. To find out VA, let us take moment towards B. You know sigma MB equal to 0. So VA into this much distance is 40, VA into 40. UDL of UDL should also be taken moment till the rightmost point. So 20 into the length of UDL is 20. Distance from center of UDL to rightmost point is 10 plus 10 plus 10, 30. So VA into 40 minus 20 into 20 into 30. Then the moment of 100 till to the rightmost point, 100 into 10 equal to 0. So VA, you get the value. Now to find VB, you should use the property that the summation of total downward forces is equal to summation of total upward forces. Total upward acting forces are the vertical reactions VA and VB. So VA and plus VB is equal to total downward acting load is 20, acting for a length of 20 meters. So 20 into 20 plus concentrated load 100. Using this, you can find, you know the value of VA, so you can find vertical reaction VB. Okay. Now to find horizontal thrust H, you should take moment at point C. So sigma MC equal to 0. That means VB into, let us take moment from B. Why? Because in the leftmost left side, you are having the UDL. If you are taking a moment from left towards C, then the moment of a UDL will also come. So calculations are little bit difficult than that if you are taking moment from right side. So let us take moment from the right side towards C. So VB into the distance from B to C is 20 meters. So VB into 20. Then distance from 100 to C is 10 meters. So minus 100 into 10. Then distance from H to C, that is the vertical distance 8 meter minus H into 8 equal to 0. Now you get horizontal reaction H. Okay. Now to find out theta, we should find out R. How we can find R? To find R, you should use the property of circles H into 2R minus H equal to L by 2 into L by 2. In this equation, you know H, you know L, you can find out R. Once you find R, then see this diagram. You can see that sine theta is equal to opposite side by hypotenuse. Opposite side of theta is, you know, the distance from left point to D is 10 meters. So opposite side of theta is 10 meter. Okay. So sine theta is equal to 10 by R. That means theta equal to sine inverse 10 by R. You know the value of R, you can find out theta. Now we will find N and Q. For that, you know the equations. N is equal to V sin theta plus H cos theta and Q is equal to V cos theta minus H sin theta. What is V? V is the shear force at the required point. Shear force, how we can find shear force? Shear force is the summation of forces till the section either from the left or from the right. So let us take from the left. Summation of forces till D. Which all forces are there? VA is there, UDL is there till D. Okay. So VA minus UDL acting till D. How much is that? 20 into distance from left to D is 10 meter. So VA minus 20 into 10. Okay, you got V. Now substituting the values, you can find N and Q. N is equal to V sin theta plus S cos theta. Substitute for theta, substitute for V and S. You got the value as 336.437 kilonewton. Similarly, using the equation for radial thrust Q, you can find out the value of Q. Next, let us see another problem for circular arch. A circular arch to span 25 meter with a central rise 5 meter is hinged at the crown and at the springing. It carries a point load of 100 kilonewton at 6 meter from left support. You should calculate the reaction at the support, reactions in the crown, and moment at 5 meter from left support. Okay, you can see the figure here. Your load is given at a distance of 6 meter from left support. You should find out the normal thrust and shear at a point D, which is 5 meter from left support. Okay, is the diagram clear? Now we will proceed like this. Likewise, the previous problem, first you should find out vertical reactions VA and VB. Take moment towards either A or B and find out VA and VB. Let us take moment towards B, then VA into 25 is equal to 100 into 25 minus 6. Okay, so VA, you got the value. Then total downward acting load is 100 kilonewton. So VB is equal to 100 minus 76, which is equal to 24 kilonewton. Now, taking sigma MC equal to 0. Moment towards C, VB into 12.5 minus H into 5 equal to 0. From this, you can find out horizontal reaction H. Then again, like the previous problem, let us find out R. H into 2R minus H equal to L by 2 into L by 2. Using that, you can find out R. Now you know that R sin theta. R sin theta is equal to what? R sin theta is equal to R into sin theta. Okay. R sin theta equal to distance from D towards the center line. Distance from left to D is 5 meters. So distance from B towards the center line is 12.5 minus 5. Okay, that is 7.5. That is R sin theta. Using that property, you can find out sin theta, and subsequently you can find the value of theta. Then we should find out the vertical length at D. Okay, YD. How you can find this length? How you can find? You can find distance for this. You can find till this distance. No, you know this distance. Then you can find the distance from this point to this point. Okay, so you can find out YD. YD is equal to H minus R into 1 minus cos theta. Okay, just like this. H, you know, H is the rise. H minus the distance till this point. Okay, distance from C to center point is R. So distance from this much distance, how we can find? This much distance is equal to R minus R cos theta. Okay, this is R, this is R, this is R, this is theta. So R cos theta, you know. So R minus R cos theta gives you this highlighted distance. Okay, so R minus R cos theta is R into 1 minus cos theta. Okay, so YD is equal to H minus R into 1 minus cos theta. Using this, you can find out YD. What is YD? YD is the vertical distance. This is YD. Okay, vertical distance of the arch under D on the elevation of the arch. Now you can find moment at D. Moment at D is equal to bending moment at D is equal to moment of all the forces coming till that section. VA into 5 minus H into 5 by D. Okay. Now we got the bending moment also. We will see all other problems in the next video.